Okay, here's more of Math 115 review for the midterm. And in this video, I'm going to start with problem 4 and see how far I get in a short video. So let's see. Problems 4, 5, and 6, and 7, and 8 are all about Boolean functions. Problem 4, though, gives us a Boolean function, P's and Q's, and asks what is the domain, and it says use the truth table to evaluate the function and determine if it is equivalent to P XORed with Q. Sorry for the typo there in the PDF. So with problem 4, basically we've got two variables here, P and Q. And so we have, when we make our truth table, we're going to have 4 rows in the truth table. That's 2 raised to the 2 power for the P and the Q. And so the domain is the set 0, 1 squared, meaning that we're going to take the cross product of the set 0, 1 with itself. And in the lazy way of writing, we call that 0, 0, 0, 1, 1, 0, 1, 1. Whereas we really should be saying 0, comma 0 instead of 0, 0 for a cross product, for an ordered pair, but we understand this notation. We could also write it using set builder notation as the set of all PQ next to each other such that P is an element of 0, 1 and Q is an element of 0, 1. And so we know there are 4 combinations, and so this is the domain, 0, 1, the set 0, 1 squared. And the truth table is fairly straightforward to analyze. We make our 4 rows, and I'll ask that you always make them in the same order here. And because there's several different pieces to this, I'm going to go ahead and evaluate them one step at a time. I'm going to do the P or Q first. I'm going to do the P and Q next. Then I'm going to negate the P and Q. And then I'm finally going to put the AND in between the P or Q and the not P and Q. And you see here that a P or Q, the only time it's false is when they're both false. For the P and Q, just the opposite. The only time it's true is when they're both true. If I negate the P and Q, I turn all the zeros to ones. And finally, I do an AND between these 2 columns, and the only time it's true is when both are true. And you can see that both are true in the middle 2 cases here. And so I get this as 0, 1, 1, 0. And if I look at an XOR means P or Q, but not both. And so either one being true by itself, but not both. And so we have a 0 for both. And you can see, yes, they are equal. Okay, so that's problem 4. Problem 5 says to consider the Boolean function g, and it's given here. What's the domain? And make the truth table, and use the truth table to help you determine a simplified form for g. Okay, so the first thing I notice about this is that it's a big AND statement. It's a sort of a triple AND statement, and in between are pieces with ORs in them. So I have to leave all the parentheses on. And here's what my solution to number 5 looks like. It has just P's and Q's, so it's just 4 rows in my truth table. And I'm going to do this one without doing all the separate little pieces, unlike the one above where I broke it out into all separate columns. And I'm going to do, hey, look at this, not P or P. That's always true. That's a tautology, so I put ones underneath that one. Not Q or P, I'm sort of doing a little bit in my head on this column and saying not Q is a 1 or a 0, and that gives me a 1. Not Q is a 0 or a 0, and that gives me a 0. Not Q is a 1, so I get a 1, and they're both, and not Q would be a 0, but P is a 1, so the OR gives me a 1. On the P or Q here, it's only false when both are false. Okay, now I have a triple AND statement. And we can either do a triple AND statement as two different AND statements in a row, putting the parentheses either place, I can either do the A and B first and then AND it with C, or I can do a B and C and then AND it with A. But what I like to do is just to consider it as a big AND statement and say, look, the only time it's true is when all three are true. And that's what I've done here. So I look for my answer. I labeled this column answer just because I guess I could have labeled this G, because it's the function G that I'm evaluating. I look for all three of these to be true. And all three are true in the bottom two cases. And now for part C, it said, use this truth table to help you determine a simplified form for G. Well, look at my answer, 0011. Hey, that's exactly what P was. And so I can write that G is equal to P. And that's the simplified form. Okay, so that's number 4 and 5. Let me go on to 6. We have a Boolean function that goes from the domain 0, 1 squared, which means just P and Q, and is mapped to 0 and 1, and that's what Boolean functions are. That's the definition of Boolean functions. They have a domain which is 0, 1 raised to some power, and if it's a power 2, we use P and Q. If it's a power 3, we usually use P and Q and R, 3 of them. And the result of the function is always either just a 0 or a 1, a false or a true. What is the size of the domain? How many possible functions are there with this domain and range? And make a table that lists all possible functions. Each function should occupy one column of the table. This one has sort of almost a whole page of an answer. So here's my Boolean function, mapping 0, 1 squared to 0, 1. The domain is 0, 1 squared. And here's what I'd like to see on an exam when it asks about the size of a domain. When we ask about the size of a set, we put these vertical lines around the set. And we know that the size of a set, I really should make an intermediate step here that says the size of that set is the size of this set squared. Okay? So when we have A squared, the size of A squared, that's equal to the size of A squared. And that's exactly what I've done here. Where A is the set 0, 1. Okay? And the size of 0, 1 is obviously 2, so this is 2 squared or 4. How many possible functions are there? Well, there's a lot of possible functions because every function occupies, every function that I can make is simply a row, a column in this truth table. And I've got 4 different rows in the truth table. And so the question becomes, how many different ways are there to assign zeros and ones in a column here? And we know what that is because it's 2 to the 4th. There are 4 columns. And there are 16 possible functions. We can also argue that by saying, look, for each function must map each of the 4 inputs to either a 0 or a 1. And so here I have 4 possible inputs, 4 rows, and the output has to be either a 0 or a 1. And so there are 2 possibilities for the first, 2 for the second, 2 for the third, and 2 for the fourth. Altogether, 2 to the 4th, or 16 possibilities. And so what I've done here is labeled function 1, function 2, function 3, and basically I did binary counting. 4 zeros, 3 zeros and a 1, 0010, 0011, all the way up to 1111. And that's all 16 possible functions, and that's 2 to the 2 to the 2. Okay? And I think at this point I will stop this video and we'll continue on with problem 7 in the next video. Hope that helps.